Hello everyone, welcome to this video. Hope you're all fine. And a short while ago I did a video on persistent volume and persistent volume claims, how you can use the claim to request storage in your Kubernetes cluster. And if you have watched that video, towards the end of the video I tried to set up an NFS server to use NFS volumes as persistent volumes for storage. But I had some issues while recording that video. So since then I played with the video, I kind of got it working, and I thought of sharing it with you guys. So in this video, I'll be showing you, let me bring up my notes. So okay, so this is my setup for this video. So I've got the Manjaro Linux on my host machine, on my host laptop, and I'll be setting up a cluster, a Kubernetes cluster using Vagrant provisioning. The Vagrant will provision the virtual boxes, and they all will be CentOS 7. Got one master node, kmaster, and two worker nodes, kworker1 and kworker2. The master will have 2 gig of RAM, 2 CPU, and each of the worker nodes will have 1 gig and 1 CPU. So in this video, what I'm trying to show you is, as I explained in the persistent volume demo video, there are lots of volume plugins that you can use. Either it can be Google Persistent Disk, Azure Disk, or Amazon's file store EBS thing, or you can use Hostpath or NFS server. There are lots of volume plugins. If you go to kubernetes.io and search for persistent volume, you'll find all the supported plugins there. So in this video, my focus will be on the NFS server. So you can have an NFS server anywhere, and you can use that as your storage volume inside your Kubernetes cluster. So what I'm going to be doing in this video is set up an NFS server on my host machine and export a directory. And I'm going to make use of that directory within my Kubernetes cluster. Right, let's dive in, and let me bring up my cluster. As usual, I'm setting to play directory. I'm going to git clone my Kubernetes repository. I'll put that in the video description. You can check that out. So that's done. And if I go to cd Kubernetes and then to Vagrant provisioning, I'm going to do Vagrant up. So this will provision the Vagrant cluster as I explained, one master and two worker nodes, and it's going to take around 8 to 9 minutes. So while it's doing that, what I'm going to do is I'm going to set up the NFS server on my host machine. If you happen to use Arch Linux, you can follow this one, or I will leave it with you to set up NFS server on your host machine or any other machine external. Okay, so if you happen to use Arch Linux, these are the steps to follow. Sudo pacman -s nfs utils. So that will be already installed. If it's not installed, so that's the only package you need for NFS server. So I'm not going to install that because it's already installed. So once that's installed, what you need to do is enable and start the NFS server service. Sudo systemctl enable NFS server. Sudo systemctl start NFS server. And if you see the status, and it's running, it's active. Okay, so I'm going to make a directory, sudo make dir /srv nfs kube data. There's only srv directory, so I need to use -p so that it creates all the directories. Okay, and I'm going to change mode to 777. You don't have to do this, but just in case if it doesn't work, change mode -r 777 to that one. And the next step is to export this directory. So the file to edit will be etc exports. So in this one, I'm going to add /srv NFS Kube data, and I'm going to export it to all the IP address range. If you know your, because I tried that, it didn't work. So I tried using the IP addresses of my IP address range of my Kubernetes cluster. For example, as I'm using Vagrant to provision the cluster, I specified the IP address to be 172.42.42.100 for master, 101 and 102 for the worker nodes. So it will be 0/24, but that didn't work. I don't know. So just for this demo, gonna put a star, which means any client can access it. Read write sync no subtree check, and the important thing is insecure. Because without this option, when I tried, I wasn't able to mount this export from inside the worker nodes. So I then had to work around and find the solution to add this insecure option. I don't know. It might be because of the different versions, maybe NFS 3 versus NFS 4. I didn't want to spend too much time on this, the NFS settings, because I need to. The focus for me is to get this NFS storage working. Okay, so insecure is the important option here. So once you've done that, you have to export it. Export fs -rav. So that's exported. And if you want to see what's currently being exported, you can run export fs -v. That tells what directory we are exporting srv NFS Kube data and to the world and what are all the options. And there's also show mount -e. So that will tell you in a short version what you're exporting and to whom you're exporting. So that's it. We are all done with the host machine. Our NFS server is working. We should be able to mount this directory from our worker nodes. So the cluster provisioning, at the moment it's initializing the Kubernetes cluster on the master node. And once it's done, it's going to provision the worker nodes. I'm going to pause the video here and come back when it's ready. All right, Vagrant has provisioned the cluster. What I'm going to do now is I'm going to copy the Kubernetes configuration from kmaster to my host machine, so that I can run kubectl command directly from my host machine to interact with the cluster. So make directory .kube under my home directory, and I'm going to copy the admin.conf from kmaster to config under .kube directory. Okay, so that's all done. Let's check the status of our cluster. kubectl cluster info. That's there. kubectl get nodes. 3 nodes, all of them are ready. Let's check the version. Okay, we are on version 1.13.2. Okay, cool. One thing I wanted to do before deploying any resource is to log into each of the worker node and see if I can mount the NFS volume. Okay, if I do ssh root at kworker1, the first worker node. Right, I'm in there and I'm gonna try mounting the volume. Let's check the IP address. Actually, it's here, 192.168.1.10. Can I ping it? Yep, I can. So if I do show mount -e 192.168.1.10, cool. So that's the directory that's exported from my host machine. Let's try to mount it. Mount -t NFS colon srv NFS Kube data to mnt. Cool, that's mounted. Mount grep kube data. Cool, I can mount it from kworker1. Let me unmount it. I'm going to do the same on kworker2 just to make sure that I can mount it. Mount -t NFS 192.168.1.10 colon srv NFS kube data to /mnt. Cool, I can mount it. Okay, so that's there. I can successfully mount the NFS volume from each of the worker nodes. Let me unmount it and exit out of it. Okay, in my GitHub repository, if I go one directory above and cd to YAMLs, I've created a couple of YAML files for this demo. One of them is the Nginx YAML file, and I'm looking for this one here, pv-nfs. So that's the YAML file for creating the persistent volume. Let's take a look at it. pv-nfs.yaml. So it's basically deploying a persistent volume resource, and the name is pv-nfs pv1. Type is local, that's just a label, it can be anything. Storage class name is manual, so whatever you give here as the storage class, you need to make sure you give the same storage class when you're claiming this persistent volume using persistent volume claim. Capacity storage is 1 gig. Access mode, read write many. There are a couple other access modes: read write once, read only, and so on. So there are like 3 options. I've given read write many. Okay. So the path is srv NFS kube data, and I need to give the IP address of the NFS server here, 192.168.10. So that's our persistent volume. Let's try and create it. kubectl create -f. Okay, that's created. If I take a look at the PV, kubectl get PV, you've got the PV, the name is pv-nfs pv1, capacity 1 gig, RWX, which is read write many, reclaim policy, which is the default reclaim policy, that's retain. You can change that to recycle or delete. Status is available. Storage class name is manual, created 6 seconds ago. Okay, now let's try and create a persistent volume claim. So I've got a YAML file for that one there, for pvc nfs.yaml. So it's again a resource of type persistent volume claim, and I've given it a name pvc nfs pv1. Storage class name manual, so we are requesting the storage from the storage class manual. This has to match with whatever you've given for the persistent volume. Access mode, again, read write many. If you give read write once or anything different than to what you have defined in the persistent volume, it will be in the pending state. It won't get bound to the persistent volume. So you have to make sure there is a persistent volume available to satisfy these conditions. And the storage we requested is 500 meg, and the persistent volume we created is 1 gig. So that should be sufficient. And if I deploy this one, kubectl create -f, persistent volume claim created. So now if I look at kubectl get persistent volume and persistent volume claim, you can see the persistent volume and the status is bound. It is bound to the persistent volume claim pvc nfs pv1, and this is our persistent volume claim, and the status is bound. It is bound to the volume pv-nfs pv1, which is this one here, and the capacity, what's the mode, what's the storage class, and so on. Okay, so we've created an NFS server, we created a persistent volume, and we have created a persistent volume claim. Everything is available. So let's take a look at how we can use this persistent volume from a pod. So I've got this NFS Nginx demo YAML file. Let's take a look at that one. It's a deployment with one replica. The name of the deployment is Nginx deploy. And right, container Nginx image, and the name is Nginx. And one different thing here is the volume section under the pod specification. So I've given it a name www persistent volume climb. So the type of volume is a PVC persistent volume climb, and the climb name is PVC NFS PV1. kubectl get PV, PVC. So you have to give it a name. You have to mention the name of the persistent volume claim that you created. And we are going to mount that inside the container under user share nginx html, right? And yeah, and the name of the volume here should match the name of the volumes you've mentioned in the pod specification. Right, let's go ahead and deploy this pod. So before that, what I'm going to do is from my host machine, I'm going to create a temporary HTML file under srv nfs kube data. srv nfs kube data index.html. So I'm on my host machine and I'm creating an index.html file on this nfs export directory. So as we are mounting this directory inside the NFS Nginx container, whatever we add here should appear. That's a good testing. So let's do something here. H1 welcome Kubernetes. H1. Okay, so that's a simple HTML file that says welcome Kubernetes. Let's go ahead and deploy this Nginx resource. Watch kubectl get all. Okay, so at the moment we haven't got any resources apart from the default Kubernetes service. Okay, so the deployment has been created, Nginx deploy, and with one replica, and the container is getting created. It should be ready in a minute. And as you can see here, the image is getting downloaded and there's some network activity. Okay, so it deployed the pod on the first worker node, K worker 1. And while it's downloading the container image, let's go to the worker node. K worker 1, I haven't mounted it, so the cluster should have actually mounted it. Let's see, mount grep kube data. As you can see here, it automatically mounted the directory from the NFS server because our pod requested a persistent volume that's available from the NFS directory. Okay, what else we can do? If I do kubectl exec -it and the container, the pod name nginx deploy sh. So I basically want to get a shell inside the running container. I'm inside the container, and if I do ls user share nginx, you can see the HTML file there. Sorry, that's the directory. ls user share nginx html index.html cat user share nginx html index.html. So that's the file there. And just for completeness sake, I'll create a service kubectl expose deploy nginx deploy port 80 type node port. just to see if we can get to the page. That's deployed, and the service is getting deployed. I think it's deployed, and the port number, the node port, is 32517. So this should be accessible from any of the worker node, either from K worker 1 or K worker 2. Let's go ahead and check that out. K worker 2, for example, because the pod is running on K worker 1, let's test it on K worker 2. 32517 is it? 32517, yeah, 32517. Cool. Welcome Kubernetes. So now what I'm going to do is I'm going to change the index.html from the NFS server itself, just to show you that it's dynamic. Welcome Kubernetes. Welcome to Just Me and Open Source. That's my channel title. I've saved it, and if I go there and refresh it, you can see welcome Just Me and Kubernetes. Cool. Let's clean it up. kubectl delete service nginx deploy. kubectl delete deploy nginx deploy. It's all getting terminated. Okay, cool. I think that's all I wanted to show you in this video. This is just an example of how we can use an NFS server as a backend. I really wanted to do this video because when I was doing a video on persistent volume, I was trying to show you guys how to use NFS server, but I didn't prepare for that bit, so I didn't really got to the point where I can show you how it works. And indeed, I was trying to show you, but something went wrong, and I couldn't figure that out. But later, I realized that you need to use the insecure option, because on that video, I tried mounting the exported volume from the worker nodes, but I couldn't. I got access denied from the server error. So now I found that it's to do with the insecure option, but that's not the right solution. But if you come across any good way of doing that, or if you know why it's not working without the insecure option, please let me know. Okay, just for the completeness sake, I'm going to clean up everything. Sudo systemctl stop NFS server, sudo systemctl disable NFS server, vi etc exports. I'm going to delete that, and I'm going to remove srv NFS. Okay, cool. That's it for this video, and thank you so much for watching this video. If you don't understand anything in this video, or if you've got stuck or any issues following this video, please let me know in the comment, and I should be able to respond to you. The time of recording this video, the version of Kubernetes is 1.13.2, but it's fast changing. I mean, they release newer versions quite frequently. So when you're watching this video in the future, things might have changed a little bit, but keep me posted in the comments if you've got any issues, and I should be able to help you with those issues. Cool. Thanks again for watching this video, and I'll see you in my next video. And don't forget to subscribe to my channel, and I've got loads of Kubernetes related videos planned in the future. And if you like it, please share it with your friends too. Thank you. Bye bye.